Hi, and welcome to Cover Your Apps, Drive Productivity with Test Impact Analysis and Code Coverage. I'm Jeff Peoples, Senior Product Manager over Functional Enterprise Products. And today I have with me Wilhelm Hocker, our Senior Solutions Engineer, who's going to take you through a live demo of these two functionalities where you can see how they meld and work together to help you deliver confidence at speed. But before we begin, I just wanted to give you a brief housekeeping reminder that if you have any questions, to please post them in the Q&A box, and either Wilhelm or I will answer those for you near the end of the session. So to get started, also, and I'm getting feedback that if my screen is blurry, first just it could be my internet, but otherwise it looks best in full screen, and just adjust your settings. But I'm also been having some connectivity issues, so but we'll get through it. So to get started, let's take a look at why we would need code coverage and test impact analysis, and what TIA even is. There's only so much work you can do in each time-constrained sprint. And as you advance in your testing practices, you accumulate large numbers of tests, which can become difficult and time-consuming to maintain and execute. And after multiple iterations of adding more and more tests, rerunning this entire test load for each build can tend to slow down productivity. One major hotelier evaluating Parasoft's products shared with us this quote, making it very clear what a time and resource saver coverage in TIA can be. And this quote from the team of testing industry guru Martin Fowler gives us the crux behind why we need code coverage and test impact analysis. If tests ran infinitely quickly, we would run all the tests all the time. But they are not, so we need to balance cost versus value when running them. So who is Martin Fowler? Well, Martin Fowler is an Agile expert, most famously known because of the research he and his team did to derive the testing pyramid first unveiled in 2012, which has proven to still be relevant today. The testing pyramid shows where focus should be allocated when testing, with the highest amount of testing conducted in areas near the bottom, proceeding to the least amount at the top. At the base of the pyramid is a foundation of unit tests backed up by a solid set of API or service level tests. These tests are more efficient, so you should have more of them. These tests can be created earlier in the software development process, are easier to automate, easier to understand, and ultimately easier to diagnose the root causes of regressions and test failures. There's less of a focus on the automated end-to-end UI and manual tests. These tests have a purpose, and manual testing is very useful for exploratory and user experience testing, but they should be minimized as they are difficult to automate, and you have to wait until the entire application and the test environment is available. And they're also difficult to maintain, and they're difficult to diagnose. And we at Parasoft believe there's actually a missing layer to this pyramid that should have the most testing focus, and that's code analysis for reliability and security. Following the pyramid as a blueprint helps you create a test automation strategy that's scalable. However, when we talk to actual real organizations, most organizations identify with an ice cream cone rather than a pyramid, with more manual or UI tests than API or unit tests, because even though they are harder to automate, they are easier to understand and define. User interfaces are more intuitive and therefore less technical, and less expensive resources can do the testing. When we dig a little deeper, we see that it's actually worse than an ice cream cone. We find that many organizations are skipping right past the API testing because it's hard to understand, and it often falls into a no man's land between dev and test roles and teams. Bottom line is that many organizations are still struggling with automated testing. And this slide gives a 30,000-foot view of our continuous quality platform, starting with are language-based products for C++, and Java, and .NET, and proceeding through SOATest, Virtualize, and Selenic, and sending their data downstream ultimately to DTP. And this goes beyond basic reporting and includes deep analytics using code coverage to deliver real value, like mitigating the pain of lengthy functional test debugging cycles by correlating what code is covered so developers identify root causes faster. Speeding up CI/CD pipelines by intelligently running tests based on what code is changing. And enabling teams with attainable KPIs for legacy projects. But it's not just about having a suite of tools. For teams to effectively begin melting that ice cream cone and driving efficiency into their quality process, there are some stated goals that we know come along with that journey, such as testing earlier. Teams want to shift quality and security to the left within sprint testing to deliver on these priorities during code development. Service virtualization is a practice that helps teams automate component-based testing reliably and early in the process, where individual teams are not beholden to the state of a shared test environment. But there's also another way of looking at the test earlier goal, which is really test optimization. A question to you would be, do your teams take the time during retrospectives to assess whether there could have been a better way to catch a defect that was found by, say, a UI test? When a defect is found with a test, teams need a platform that facilitates analysis of whether there's a better test that can catch this defect. For example, we know developer-led testing practices like static analysis and unit testing have a transformational impact on positive software project outcomes. What bridges the gap between development testing and QA testing is code coverage. Measuring code coverage, not just from unit testing, but also functional testing, opens the doors for teams to ask the questions like, is there a better way that we could be catching this defect in the future? And of course, another important question, what aren't we testing? Next is to test faster. If all you have is a hammer, every problem begins to look like a nail. Organizations struggle with optimizing their testing strategy to fit within the parameters of agile and modern software architectures, and the inability to accelerate can stem from a variety of places. For example, a functional test at the UI layer will always be slower and more expensive to maintain than testing the same functionality via APIs. Question to ask yourself, have you seen any UI-heavy testing practices hit scalability walls when trying to adopt agile development in your organization? Because organizations need a platform that enables them to efficiently build the right test and not just a test. And this is where AI technology can assist with transitioning a UI-heavy testing practice to a lean UI-heavy testing practice, where a lot of end-to-end functionality is verified at the API or the service layer. But it's not just about shifting as much functionality testing from the UI down to the API layer. Yes, with that shift comes speed, but there's even more speed to extract. And this is where code coverage also bears more fruit. You don't want to run your entire regression suite with every pull request. That's way too slow. You want to run exactly the right tests that are impacted by the code changes in that pull request. And this is what we call test impact analysis, or smart test execution. Lastly, we have test less. An organization's maturity in automated testing increases, so does the volume of testing that takes place. Having more tests doesn't necessarily equate to a higher quality, but we know for a fact that it equates to a higher maintenance burden and a longer deployment process. So while it may seem counterintuitive, Agile also means being smarter about what tests you're running, in addition to regular reviewing the measurable outcomes of your quality process and seeking opportunities to prune the tests that are no longer relevant or valuable. And again, these optimizations come out of the measurement of code coverage across all testing practices. Enabling automated testing with the right tools is one aspect of a successful transformation, but the other, often overlooked aspect, is having a platform that highlights the KPIs coming out of these practices that let your teams continuously improve. And this is where AI-powered test impact analysis comes in. TIA analyzes your build, and the artificial intelligence determines what code changed and which tests are associated with those modifications, and then runs only those tests, which speeds up productivity substantially. Instead of slowing productivity as iterations continue and test volumes increase, you maximize delivering quality at speed. Test impact analysis is a game changer for many of our clients. When we consider how code coverage can help us melt that ice cream cone and more appropriately allocate our testing practices, we find three types of coverage: manual testing coverage, functional testing coverage, and unit testing coverage. Parasoft Continuous Quality Platform is capable of capturing and analyzing all of these to determine an overall coverage value. So how does it work? We know organizations set high coverage goals as a metric that is used to improve quality. This is because every time developers change the code to fix bugs or introduce new features, they run the risk of introducing regressions. For many teams working on brownfield development projects, high code coverage is a difficult or unattainable goal when they balance other business objectives. However, the same can't be said for newly written or modified code that's within the scope of a sprint or a release. One way to help Agile teams stay agile without impacting quality is with our modified code coverage analytics. Our Quality Insights platform, DTP, receives build data from your CI/CD process and lets you diff between a baseline build and a target build. And this means that even if your overall coverage doesn't meet your development policy, the team has an attainable goal for their modified code. Running these analytics throughout the sprint cycle is also helpful because teams get real-time feedback on whether their current regression suite is delivering sufficient coverage of the modified code, or if new tests need to be written so they don't get uncomfortable questions during a sprint review. The next way code coverage can play an impactful role in Agile development processes is by delivering massive performance gains in the CI/CD pipeline. When you look at robust testing processes, that includes static analysis, unit testing, integration testing, and UI testing. These practices all add time that means development is stuck waiting to see whether the pull request in their feature branch is of good quality. A lot of organizations tell us they have a hard time completing their testing in sprint, and coming up with a pared down commit suite doesn't catch the issues that a full regression does. And we need to improve how tests are executed without sacrificing the fidelity of testing. And it starts by mapping tests to code coverage. Then we look to see what changes between a baseline build and a target build. Teams often set their baselines to be a build from the beginning of a sprint. Lastly, we only execute the tests that are impacted by the change. And we have this for Java-based unit tests for both in the ID and the build, API testing with Parasoft SOA test, and Selenium-based testing with UI testing through Parasoft Selenic. These are Jenkins trend graphs that our dev team pulled for some of the runs they deal with. Our CI test run has more than 4,000 tests, And this graph shows the number of those 4,000 tests that ran over a period of a few weeks in the TIA test run. Now, just improving the time it takes to run a healthy regression for every pull request, which might be infeasible today, but consider cloud costs for keeping an environment up for testing. There's a lot of computation that goes behind running your full suite of regression tests, and running only the impacted tests represents a hidden savings you get by being more efficient with your testing process. And here's a quote from a happy client who has implemented our coverage solutions. With a focus on best practices for aligning traceability with the test management, the team knew exactly which lines of code were being executed and tested inside of that application to validate all changes that had been verified. This analysis capability, known as change-based testing, was a determining factor in the team's selection of Parasoft as a solution to support and enhance their agile workflow. And it seems we've now come to the demo portion of our webinar, feedback. So this is where I will hand it off to Wilhelm.
All right, thank you, Jeff. Let me just get my screen share going. All right, so here I'm showing my browser. I'm looking at our GitHub project, one of our demo applications, Parabank. We use this for training. We use this for demos. This is a Java-based Spring application. It's got a web interface. It's got APIs. And so we run the full gamut of Parasoft's continuous quality suite against this application. And today, we're going to be looking at two branches here in Parabank. And specifically, this Selenium demo branch has some code changes to it that hasn't been merged to the main branch yet. And so the issue that, as Jeff has been describing, is, if we've got a large volume of tests, what can coverage analytics bring to the table to help us quickly validate that these code changes in this Selenium demo branch, don't represent any regressions or issues, so that they can safely be merged back to the main branch here. So I'm going to start off by showing you here my Jenkins dashboard, and what I'm doing is kind of a full build of the original, so the main branch of Parabank, deploying it on Docker, running unit testing, static analysis, Selenium tests, API tests, kind of doing a similar build with the feature branch, running all the tests as well. And so here we can see the test job takes about 4.5 minutes. This is the main branch updated. So this would be the feature branch. We've got similar test results here. Parasoft Selenic offers self-healing for your Selenium-based UI testing. So when I do Selenium demos, I talk a bit about self-healing as well. But here, what we're here to talk about today is test impact analysis. And one thing you'll notice is the build time is significantly reduced. And so what that means is we're intelligently choosing which tests to execute based on the differences between the code differences between what's in the main branch and what's in our feature branch. And so to kind of show you our Selenium tests here, this is a report that Parasoft Selenic generates for Selenium test executions. And you'll notice we've got 3 test runs. And so in my demo environment, I don't have thousands of tests to have an impressive time difference like Jeff showed from kind of our dev testing. But nevertheless, here I've got 3 tests that I'm running. So bill pay, create account, request loan. And if we take a look at the Selenium report for our feature branch, you'll notice that we just have bill pay test that got executed here. So how did this happen? Let's explore a bit how that happens. And to do that, I'm going to use DTP to kind of dig into the evidence here. And so, as Jeff mentioned, DTP is a central part of our continuous quality platform where it provides quality insights and analytics coming from static code analysis, unit testing, code coverage, as we'll see, and functional and non-functional testing. Pretty much the entire suite that Parasoft has here. And DTP is architected around builds. And so a lot of the analytics that you're going to see are the result of being able to compare a baseline build with a target build. And when you're working in an agile workflow, it's really important to be able to focus not just on the overall quality of your projects, but also focusing on the impacts of change to your code base. All right, developers are making code changes every day, bug fixes, new features are getting completed. And so you need to know from all of the testing practices that you've automated, what is the state of your projects that are impacted through all these changes that are occurring. And so I think to start off, let's look at those code changes. And so similar to a source control system that'll show you differences in code, as DTP receives build data, we're also able to kind of diff between one build to the next build to see what code is changing. And here I want to highlight pay.java. So this is one of the main classes that got changed going from the main branch and our feature branch. And so the developers added some things, right? Instead of a phone number, they added a new class, contact information.java. And so this pay.java is kind of the main source of the changes that the test impact analysis is using to determine which tests to rerun. And so if I jump into one of the other explorers here in DTP, our coverage explorer, here we can see I'm looking at code coverage when we ran our tests against the main branch. And if I look at pay.java, right, I know this is the class that changed from the main branch to the feature branch. I get code coverage from the testing practices against this class. And here we can see bill pay test is the only test that's contributing code coverage to this class. And so that's why the test impact analysis only chose to run the bill pay test and not the other tests that I had in my suite. Right? So we're using this code coverage data to make that determination of which tests to run. All right, now coming back to our dashboard here, let's explore coverage a little further. So you'll see that I've got a variety of widgets here. And I should mention that these dashboards are fully customizable, right? We've got development teams internally at Parasoft that use DTP heavily, right, to demonstrate the evidence of the quality of their projects in every sprint review. Teams can develop dashboards that suit the specific needs that they have using the data that's being published to DTP. And so here we can see I've got total code coverage for the Parabank application. So this includes unit testing code coverage, API testing code coverage, or Selenium testing code coverage. And we could even configure code coverage to come from manual testing. So we do have the ability for manual testers to log code coverage as they're going through their manual testing sessions. And we merge all that coverage together to give you a true sense of what your application coverage is, right? What parts of the code are really being tested or not tested from the full gamut of your testing practices that you have against that project. Now, this widget here, modified code coverage, is especially valuable when it comes to agile methodology. So you'll notice, right, our code base is about 4,300 lines of code, right? And we've got our overall coverage here. Now, if you'll notice, 34 lines of code have changed between that main branch and our feature branch. And so, this can be very valuable when you're looking at in sprint testing, right? Or even just testing for a given release. You want to know that this modified code is well tested because not every team starts with all of these software quality practices in mind from day one. We work with a lot of organizations in brownfield development. Development policies mature and evolve over time, so you might not have the coverage that you're really looking for on day one once you start measuring coverage. But nevertheless, modified coverage here gives the team an achievable milestone in each sprint that says, okay, we've modified 34 lines of code in this sprint. Let's make sure that we've got tests that are covering this modified code. This application, it's in production, customers are using it. We've got our process in place, for the functionality that's there. As we're fixing bugs, as we're releasing new features and making changes to this application, let's make sure that we've got sufficient test coverage for the code that we're modifying. And so this can be very helpful to dig in and see, okay, do we need to expand what tests we have in our regression suite to cover this code? And so if we look at our contact information class, so this is a new class that got added in the feature branch. We can see 75% coverage, and here line 23, this get email method wasn't covered. And so I know that the bill pay test that I used that covers pay.java and contact information, the team added a new field, an email field, to the form when you're submitting a bill pay. So here I can see evidence that my Selenium test is not filling in this optional field on the form, and we're not getting code coverage here. So here's some evidence that I need to improve my functional test for email. And now, if I come down here in the equals method, we can see there's a portion of the equals method that doesn't have code coverage as well. And this looks like a good opportunity for a unit test, in fact, right? Like these types of core methods in the classes, this is the type of logic that unit testing can really help to kind of fill in those gaps that functional tests would have difficulty covering, right? And this would be an area for a unit test to expand our coverage even further. And so modified coverage, we can drill in and really start asking those pointed questions as a team, right? Like what kind of test is the appropriate test to cover this code that we're not covering with the tests that we have, right? And from a management perspective, are we meeting our development policy using code coverage as a metric to guide us on how many new tests we need to write? Our existing suite, how much is it covering? Where do we focus? Because if you just look at the overall number, it can be difficult to pull apart what to do with that number, right? If it's not high and it's not meeting the policy that you have, then you're kind of left guessing, right? But here with modified coverage, this gives the team um, achievable marching orders, right? How they can work within a sprint and within a release to make sure that the new code they're working on is of high quality. Now, if I come down a little further here, there's another widget I felt would be nice to point out related to our topic here on coverage and test impact analysis. So we have a change-based testing widget where DTP can also report um, kind of the same TIA information that we automate with our CI pipeline. And so here, files impacted by change, we'll notice pay.java has one test that's been flagged for retesting. So if I drill in, sure enough, it's that bill pay test, right? Our automation picked up bill pay test and executed just this one as part of the CI workflow. But DTP is reporting the same thing here. And this can be especially useful when you have a large suite of manual tests you're capturing code coverage with, and you want to work with the team to determine what the optimal set of those manual tests is to rerun based on these code coverage analytics. And if we look for bill pay test, we get some really great details here. You'll notice some other things about DTP that are nice. Say this test was failing, I could create a task or a bug in Jira or Azure DevOps or a number of other systems DTP supports, and get this scheduled for the team to review and remediate, right? And it gives a nice link back to DTP so they can review the details. If it's an API test, we would see request response traffic. And another thing that's quite useful here is because we are associating code coverage down to specific tests, we can see what our code coverage was for this individual test, right? So I navigate the code coverage here, JDBC customer DAO. Here, now I'm looking at the source code, not the Selenium test code. And so this can also be helpful because functional tests often cover a lot of ground in the code base. And sometimes you want to see, is the functional test actually covering the code that we think it's covering? And if not, why, right? Is there something about the flow and the UI that we're missing to cover the code we need? Is the code that's not being covered by our functional test difficult to cover from a functional test? Do we need to consider an API test or a unit test to fill in those gaps? These coverage analytics, where we associate coverage to tests, allows the teams to start asking these kinds of questions that's going to have a dramatic impact on their process around process improvement. So that's kind of what I had to show you all today. I encourage you to leave some questions in the question box so that we can get to them at the end. Jeff, do you want to switch back over to your side and we'll continue?
Sure. Thank you, Wilhelm. That was an excellent demo. It's great to see, like, down at the CI/CD level, Jenkins, what's going on there. Okay. Everybody see my screen?
Yes.
Okay, great. All right. So now, just to review, we want to test earlier. We want to shift our quality and security to the left with in-sprint testing that lets us know early in the SDLC the percentage of code that we've modified has been tested and that we've met our coverage goals and KPIs. Code coverage is what bridges the gap between dev testing and QA testing and is instrumental in answering the questions, is there a better way we could be catching this defect in the future? And as well as, what aren't we testing? We want to test faster. As Martin Fowler's quote talked about, we have to balance cost to value when determining what to test and to be strategic with our testing practice to get through the testing portion of the SDLC faster. Companies need to transition from UI-heavy testing practices to lean UI testing practices to develop the right tests and not just a test. And we want to test less. As sprints go on and the count of tests goes up, we need a way to focus our testing so that we're testing only what was changed in the build and not wasting precious time testing what didn't change. Test impact analysis, TIA, is that tool you need to streamline and laser focus your testing and deliver confidence at speed. And before we move on to questions, did you know that you could have a voice in guiding the future of Parasoft products? Check out forums.parasoft.com and learn more about submitting your product ideas or upvote others' ideas. And if you're not a member yet, create your account to get started. It's a great place to interact with other Parasoft customers, to ask questions, and to get answers. And be sure to check out parasoft.com website for additional information, including ebooks, white papers, blogs, case studies, and more. And that's about all we had planned to show you today. So let's go to the Q&A box to see if we have any questions. And we decided that I would ask the questions and Wilhelm would answer them. So first on, pretty obvious. Wilhelm, what languages do you support for TIA?
That would be Java, Jeff.
Okay. And what languages do you support for code coverage?
So for code coverage, we support both Java and .NET. And so I think .NET, we're looking at expanding the functionality there for TIA. So yeah, for measuring code coverage from your testing practices, whether it's .NET application in IIS or a Java application, running on Tomcat or some other way, we can collect the code coverage, give you the modified coverage analytics, but TIA is just Java today.
Okay, thanks. Okay, here. How do you capture code coverage for manual testing?
So we have a coverage agent manager web application, and this is a nice UI where manual testers can record code coverage while they're going through their manual testing sessions. And so this data can be published to DTP, just like a Selenium test or API test publishes data. We can offer a workflow there for manual testers to publish their test results and their code coverage into DTP as well.
Okay, it looks like we have one more, unless anyone else wants to submit other questions. But is your code coverage solution SaaS-based, where code coverage data is sent to Parasoft for processing?
Good question. We have a lot of customers that are very sensitive about their source code and their IP, and so our solution is fully on-prem and within your network. None of the coverage data, none of this data ever gets sent out to Parasoft. DTP or the rest of our continuous quality suite. This is this can all be deployed within your network and on-prem for you.
Okay, thank you, Wilhelm. Apparently, wait, I see a new question. Is there any reason for not providing the feature for C and C++ code?
Good question. I think it's a matter of prioritization.
Yeah.
Product management can.
Yeah, this is my fault,
review
right?
that.
Okay, here's another one. How do you differentiate the test coverage overlap in unit API and UI testing?
Good question. So because we are capturing not just the coverage, but correlating that coverage to tests, when you are exploring coverage for, say, a particular class, you can see what tests are contributing that coverage. Um, and so, one way to look through the data in DTP when it's showing the coverage is to see, which classes, have a lot of unit tests or maybe no API tests when there should be API tests, or we've got a lot of UI tests, but not enough unit tests for this class. So you can see the distribution of the various tests you have with the coverage for a class, to kind of make those determinations about how the testing practice should evolve to better fit your needs.
Great. That had a second part to that question: how to decide where to trim additional tests and still keep the better overall test coverage. Do you think that was answered?
Yeah, yeah.
Yeah. Okay.
I think it's part of the same answer, right? You're looking at the coverage from for a particular class with the tests you have, and then you see which tests are contributing which coverage for that class. And if there are tests you need to trim, you make that determination looking at the data.
Yeah. Great. Okay. That seems to be all the questions that we have. Thank you all for attending. Thank you, Wilhelm. And have a good day.